Welcome to the Summit Speaks, presented by Summit Edge, where we explore the digital transformation redefining the global supply chain.
How do you think the supply chain industry is really, when it comes to adopting AI and machine learning? Where do you think we're at in the life cycle there?
Yeah. Well, in simple terms, I'd like to describe AI's impact on supply chains in three words. See, think, and respond.
Mhm.
Seeing is through better visibility into data. The thinking is through predictive analytics and machine learning. And respond is through faster and more automated decisions.
AI promises better decision making where we're kind of at in the life cycle right now, but many companies, as you correctly said, are still hesitating to rely on it. Do you think it's because it's a real challenge technologically, or is it just a trust thing?
I think at this stage, the bigger barrier is trust, not just technology. Forecasts are not the end goal. The supply chain decisions are. So in other words, forecasts can't really serve as the anchor anymore. The key anchor has to be the decision. So in my view, the real threat is not the next shock. It is decision latency.
Hello, everyone. Welcome to the Summit Speaks, where we explore the role of technology and AI and how it's transforming modern supply chains. Today, we're excited to welcome Dr. Agrawal, a Interim Dean of the Leavey School of Business and a professor of supply chain management and analytics. His work focuses on machine learning and advanced analytics and how it's reshaping supply chain planning and decision making. In this episode, we'll dive into how AI is changing the way organizations build smarter and more resilient supply chains. So welcome, Dr. Agrawal.
Well, thank you very much, Manjot. It's a real pleasure to be here on this podcast with you. This is really a fascinating moment for supply chains. A lot of changing because of advances in AI. So I'm looking forward to this conversation.
Yeah, same. And couldn't be more excited here. So let's dive right in. How do you think the supply chain industry is really, when it comes to adopting AI and machine learning? Where do you think we're at in the life cycle there?
Yeah. Well, in simple terms, I'd like to describe AI's impact on supply chains in three words. See, think, and respond. Seeing is through better visibility into data. The thinking is through predictive analytics and machine learning. And respond is through faster and more automated decisions. So when these three things come together, companies can move from reacting to disruptions to anticipating them. So the potential is very real, but the maturity across industries is very uneven. Some leading companies like Amazon and Walmart, they're using AI at scale across forecasting, inventory, logistics, but many other companies are still just experimenting with isolated pilots. So I'd say that supply chain AI is moving from experimentation into selective scale, but we're definitely not yet at full maturity.
Yeah, and I love the three there, like to really break it down. So in this portion here, AI promises better decision making where we're kind of at in the life cycle right now, but many companies, as you correctly said, are still hesitating to rely on it. Do you think it's because it's a real challenge technologically, or is it just a trust thing?
I think at this stage, the bigger barrier is trust, not just technology. The algorithms themselves have become very powerful, but managers hesitate when they don't fully understand how the system is making decisions. A good example is UPS's Orion routing system. Right? The analytics could optimize routes far better than manual planning, but adoption took time because drivers had to trust the recommendations. Now, over time, as the system proved itself, that trust grew.
Yeah.
So what we are seeing now, I think, is the rise of human-in-the-loop systems, where AI generates recommendations, but humans maintain oversight. So that balance is what builds confidence, and that's what's going to make adoption possible.
Yeah. It's interesting because it almost seems like as we shine more light on the black box behind the scenes, it seems like there's this magical fairy in the background. Like that's how AI is almost perceived, that it's not something that's tangible that you can kind of look at and see. Because it's making decisions in the background, people have a tendency to be a little afraid of that until you get into the weeds and you figure out how to implement it in the right way. That does change. And to your point, it's going to take some time for that process to build. So if a major disruption happened tomorrow, how quickly could an organization realistically adapt in supply chain decisions?
Well, now you're talking about one of my favorite topics, which is
Yeah.
supply chain resilience, or the ability of a firm to effectively recover from significant disruptions. This resilience really depends on two things: immunity to disruption and the ability to recover quickly.
Mm.
Now, immunity comes from preparation, right? So, for example, what we are seeing right now with what's happening in the Middle East, countries with planned strategic energy reserves or energy alternatives, they are less vulnerable to shocks. But those without, they are the ones facing consequences. Recovery comes from many things, but among them, visibility and decision capability. So, for example, during the pandemic, Toyota handled the semiconductor shortage much better than competitors because it had mapped its multi-layered supplier network and maintained strategic buffers following previous disruptions.
Yeah.
And that visibility really allowed them to adjust production much faster. So resilience is not just about having AI somewhere in the organization. It's really about having real-time data, analytical capability, and decision processes that allow you to act quickly when conditions change.
Yeah. Yeah. That data to decision timeline is what it should actually help, right? And I love that example because like right now and it does tell you about some of these companies and the fragility of some of the planning when I mean we've only been in a conflict for about a month and we're already starting to see disruption. It alludes to how for the businesses that do take these things into consideration and using and having AI as an assistant to that, as a co-pilot to that, can help model out these scenarios and help you build the right resilience, right? So
Absolutely.
it's fantastic. So many companies we were talking about forecasts, still heavily rely on forecasts. Do you think the industry may be overestimating the value of the forecasting? You've written a fantastic paper on this, so I'll let you speak to that.
Yes, I do. I think forecasting is important.
Correct.
But I do think that the industry often overestimates how much forecasting can solve problems. First, in most companies, as you will know, there is almost never a single forecast. For example, in case of a consumer electronics company that we work with, the sales team had its forecast. The
Hmm.
inventory team had a separate forecast. And the CFO's team came up with its own forecasts. These forecasts are all different from each other. And they were all different from the forecast made by their customers, who are their key retail partners. So it's not clear which forecast is the right one to use. Forecast accuracy depends very crucially on when the predictions are made, the level of granularity at which the forecasts are made, and the methodology that's used to make the forecast. So the problem is when decisions depend entirely on forecasts, any errors get amplified. So I guess the key insight that I'd like to offer is that forecasting should not be the goal. The goal really is the decision.
That's right. That's right. And I think that's so I've worked in supply chain my entire life, so people live and die by their forecasts. So and it's absolutely true. Like when I, my time at Amazon, we would have a top line forecast, call it our master operating plan, and then each business unit would create their own version of that for their S&OP and planning cycles, and then regionally we would cut that S&OP to its micro levels and then add our own like predictions to it, and then at an operations level, at the individual site level, there would be another version of that forecast and how you actually plan it. And then at the individual operator level, you would plan your labor with your own cut of that forecast. So it's like where it started as a master operating plan, it got cut like 5 times to actually then run the operation. And this is a very sophisticated operation in Amazon, but even still, there is still and deviations from the even that forecast were like anywhere from 10 to 12%, right? So like, and at the scale of Amazon, that's hundreds of millions of dollars, right?
Huge.
So we kind of talked about the different business teams and how everything has its own version of the forecasting. So how do different stakeholders like sales, finance, inventory, logistics actually come to a single agreement?
Yeah. Well, I mean, the example that you gave has really hit the nail on the head. So in theory, obviously you want these different stakeholders to be very aligned. But in practice, as you gave the example, not so much. It's kind of like herding cats. Sales tends to be very optimistic because they
Right.
want to protect revenue.
Right.
So they never want to be out of stock. Inventory planners worry about excess stock. So they tend to underestimate demand so that they don't get stuck with excess inventory. Finance focuses primarily on working capital. Logistics worries about what can actually be executed.
Right.
So I think what looks like a disagreement about forecasts often is really a disagreement about incentives, right? That's
Correct.
really the key.
Yeah.
So that's why I think planning processes and the planning process is often as much about intra-organizational negotiation as it is about analytics. At the end of the day, these incentives play a huge role in not just the forecast, but also ultimately how the decisions are made.
Yeah. Yeah. And aligning, and we've talked about this while I was in your classes, aligning incentives is actually how you remedy some of this problem rather than trying to get to one forecast. So that's awesome. So when different teams kind of maintain their own forecast, how realistic is it to have that one source of truth, though?
Well, especially in the context of planning, I think the idea of a single source of truth sounds great, but it's often unrealistic. As we just said, different teams see the world differently. And that's not necessarily a bad thing. I think what matters more is a single decision framework or a system where these different views of demand can be considered, constraints are visible, overall objectives are clear and agreed upon, and the final recommendation is transparent enough so that everyone can understand how it was produced. So, in other words, alignment around decisions matters much more than forcing everyone to agree on one forecast.
Right.
Now,
Right.
that said, I will say, since you talked about the single source of truth, in operations, a single source of truth is critical, right? If a retailer can't show accurate inventory across stores and warehouses, the customer leaves.
Yes.
If your in stock button is a lie, the customer leaves.
Yeah.
The truth is not just for planning, it's a customer retention tool. It's about revenue.
Right. Right. Right.
So, this idea of a single source of truth is very important. But in the context of planning, I think really what matters more is a single decision framework.
Yeah. No, that's a great way to frame that. So, in your experience, is supply chain data typically centralized and actionable, or is it still very scattered amongst various different ERPs, Excels, dashboards, emails? Like, what are you seeing in a traditional supply chain business?
It would be nice if they were all centralized, wouldn't it?
Right, right.
I'd say it's improving, but it's still far more fragmented than most people outside the field realize. Even in large, sophisticated companies, and you give an example as well, you often see ERP data, spreadsheets, planning tools, dashboards, and emails, all of them being used at the same time. The problem isn't just where the data lives. It's often not at the right level of detail that
Right.
is needed for a decision. So, for example, going back to forecasting, sales may have forecasting data in dollar terms.
Mm-hmm.
Planners may have this need it in unit terms, but in monthly buckets. And inventory managers may need it in unit terms, but in weekly buckets of time. So different levels of granularity. And the problem is that reconciling such differences in the levels of granularity can often be a very complicated exercise. The second really important issue with data is whether it is organized and formatted in a manner that lends itself to use by AI or machine learning models.
Correct.
And
Yeah.
whether it can be easily updated as new information becomes available. So therefore, having an AI-ready data architecture is also critically important.
Yeah.
I'd say that fragmentation and format are both barriers to using AI effectively because AI really needs clean, connected, decision-ready data, not just lots and lots of data.
Yeah, absolutely. Yeah, and that's also the other challenge is because AI is still relatively new in our ecosystem of supply chain, our data was never built to sustain that.
Exactly.
Data architecture is one, like, it's AI is definitely not a silver bullet, and a lot of times that's like you hear it around the industry, like we just slap AI on top of it, like that doesn't work. That's not gonna, and your good data in is the only way, or your bad data in is gonna be bad data out as well.
Exactly. And
Yeah,
good data and the relevant data,
relevant. Yeah,
not just any data.
absolutely. So coming back to the concept of planning, so many companies run a about monthly cycle for S&OP, but I mean, we know as you rightly mentioned, there's disruptions all over the world at various different times. Is that planning speed still good enough?
Well, monthly S&OP still has value as a coordination process, but by itself, it's not fast enough anymore. When demand, supply, and transportation conditions are changing continuously, you need something underneath that monthly cycle that can respond much faster. So again, going back to the example of what's happening right now because of the turbulence in the Middle East, companies and countries need action right now to meet their energy needs. Waiting for, say, the next Thursday of the next month when our next S&OP meeting will happen to discuss this blockade, it's just not going to work. So in that sense, relying solely on monthly planning cycles, it's kind of like bringing a knife to a gunfight. So what we are seeing now, I think, is the need for two layers. A slower cycle could be monthly for alignment purposes, and a much faster analytical layer that can update decisions and make recommendations whenever conditions change.
Yeah, real time or near real time.
Exactly.
Yeah, absolutely. So, do most organizations rely on this traditional predict then optimize approach for planning, or do you think that the model is starting to break down a little bit, and especially now with compute and this layer of AI, how are you seeing the trend in the industry?
Yeah. Well, I think most organizations still very much follow this predict then optimize process, which is also called as the PTO process. First, you forecast, then you plan inventory, production, and logistics based on that forecast. It works reasonably well when the environment is stable. However, when that's not the case, that's when things start to break down. So as we've discussed, there are multiple actors, there are misaligned incentives, fragmented data sources, separate forecasting timelines and processes. All of these drive significant and often compounded errors.
Yeah.
So clearly, decisions which are going to be based on erroneous forecasts are going to be inefficient. So the key, very counterintuitive insight is that forecasts are not the end goal. The supply chain decisions are.
Yeah.
So in other words, forecasts can't really serve as the anchor anymore. The key
Yeah.
anchor has to be the decision. And so therefore, we need an approach that's different from the predict then approach or PTO approach.
Absolutely, absolutely. So we're talking about all this like adaptation and change and where we should go. So what would you propose is the alternative approach, and what would you recommend to businesses out there?
Yeah. Well, based on research that my co-authors and I have done and an experience working with companies, we published a paper in the Harvard Business Review not that long ago, where we described the key idea behind a new paradigm that we have developed for supply chain planning. We call it as the optimal machine learning, or the OML method. So the driver behind this OML framework is the insight that even if we had perfect forecasts, that wouldn't be enough to make the best supply chain planning decisions, because those decisions must also take into account a variety of other factors. For example, there are constraints in a supply chain, production capacity constraints, logistics constraints. There may be regional or customer specific requirements. Profitability might differ by customers or by region. So even after a forecast is available, a fairly complex problem remains to be solved to ultimately determine the most profitable and the most cost-effective inventory strategy related to supply chain decisions. So this key insight really motivated the basis of our method, which replaces this traditional two-step PTO process with a single-step process, essentially bypassing the forecasting step. So our approach essentially determines a mathematical relationship between the input data and the final supply chain decisions. And of course, these decisions have to be made in such a way that they optimize the most important KPIs, whether it's profits or margins or service levels. So think about a mathematical function, or a decision function as we call it, that assigns optimal weights to all the different drivers of any inventory related decision, for instance, which can then be used directly to make recommendations about all the planning decisions, which is what we are ultimately interested in. Of course, if a forecast is available, our model can use that as an input as well and assign it the appropriate weight, but it's no longer the focus of the process.
Yeah.
And this approach now works. It's practical now because we have the data, we have the compute power,
Yep.
and advances in large scale optimization methods. And that's what's needed to make it work for problems at scale.
Yeah. Yeah. That's and I think again, it's real time, quickest path to decision rather than you know, trying to rely on some historical data, right? It's
Exactly right.
real time in the moment, right? So when you're planning these systems to generate these recommendations, how often are you finding managers overriding them? And what would you say about the trust in the technology?
Yeah. Well, overrides are very common. At a semiconductor equipment company that we work with, supply chain managers routinely spend hours overriding recommendations generated by fairly advanced planning solutions. And to be fair, their overrides did improve the resulting solution. So, that's fair. Now, part of the reason for this is that systems may not have fully earned the user's trust, as we discussed before. Sometimes the model may be wrong, but often the issue is that the model can't explain itself in a way that makes sense to the people using it. And if
Mm,
managers don't understand the logic, they'll fall back on experience, and that's completely natural and the right thing to do.
yeah. Yeah.
The other reason is that the underlying analytical model may not have accurately captured all the relevant subtleties of the business environment, because
Yeah.
no
Yeah.
mathematical model can.
Absolutely.
So the model may have assumed away some complexities just to gain tractability. So obviously, the answers will have to be tweaked to reflect reality, and this requires the user's domain expertise. So I'd say the challenge is credibility, its interpretability, and model completeness. The goal should never be to remove the humans from this process, but
Yes.
really to build systems that the humans can trust, build systems that can respond quickly using the most recent data, but provide solutions in a way that is understandable and that humans can trust.
Yeah, no, and I think the being able to understand, right, the logic as to why the answer was driven or why that decision was recommended. I think that also is it helps multitude of things. It helps you deep dive whether the model is complete enough, right? Like, do we have all the right inputs and data? Do we have we assigned the right weights to this decision making logic? But ultimately, then it also alludes to your second point around trust that now I know why it's doing what it's doing and I can trust that the decision output is right. And it will take some time. So little off center here. How long do you typically um, refine and tool till the model becomes sustainable enough?
Yeah. Well, I think that depends on the maturity of the processes within a company. So, in the semiconductor equipment company's example that I gave, that company was fairly mature in terms of its planning process. They had very good data, very clean data. Formatting it in an AI ready form was actually pretty easy. In an example like that, applying these kind of methodologies can be very quick. The second example that I gave, the consumer electronics company, was much earlier in their evolution. And so that was an example of a company where the data was highly fragmented, highly distributed. Their
Yeah.
planning processes were relatively nascent. And so there, it took us a lot longer. It was several months. And a big part of that was just getting the data pipelines ready, getting everyone aligned on the potential value from a new way of thinking about planning.
Yeah.
So it really had to do with how ready the company was, how mature their planning processes are.
Yeah, absolutely. So, do you see this concept of digital twins becoming essential for supply chains, or are most companies still far from being able to model their networks end to end?
Yeah. Digital twins are becoming essential, but most companies are still somewhere in the middle of their journey. A lot of firms can model parts of their network, but building a true end-to-end model that includes suppliers and their suppliers and plans and inventory and transportation and customers, that's what we need, but that's much harder. I think what's changing now is that the technology finally makes it practical to do this at scale.
Yes.
And companies are starting to see that without a network model, it's very hard to respond intelligently to disruptions. You're just picking numbers out of a hat. But having a complete comprehensive digital twin can fundamentally change how we think about planning.
Yeah. Yeah, absolutely. So if companies had a full digital twin in their supply chains, how could that change the way that they test disruptions and plan responses to those disruptions?
Yeah. Well, it changes planning from guessing to
Right.
experimenting,
Yeah.
right? The
Yeah.
digital twin can be used to perform what if analysis using
Hmm.
historical data. And the analysis could quantify network wide effects on KPIs that matter very accurately. And that can help formulate well informed strategies to deal with supply chain challenges. But more importantly, instead of worrying about what we should do if something goes wrong, the
Hmm.
digital twin can be used for future scenario planning.
Yep.
Right? So, for
Optimization.
example, what if the shipping lead time from Asia doubles because of a blockage on a major shipping route? Or what if a distribution center is rendered inoperational due to an earthquake? Which specific regions or customers will be impacted and by how much? So, in each of these cases, we need to know what's the most effective risk mitigation strategy. So, the key is to be able to quantify the impact at the appropriate level of granularity by product, by region, by customer, or whatever is the right level of aggregation. The digital twin, combined with the OML methodology that I previously talked about, offers the ability to conduct this kind of analysis. And it is this sort of analytically driven capability that can help managers devise supply chain and logistics strategies to build agility and resilience in their supply chains. You can test scenarios before you make real world changes. And that makes decision making much faster and can offer those decisions with much more confidence.
Yeah. Yeah. Awesome. Yeah. So then if AI could directly connect supply chain data to these operational decisions in real time, how would that change the ways that organizations would manage their inventory and production and logistics and other their business laterals?
Yeah. Well, essentially it would shorten the loop between sensing and acting, which is really the ultimate goal.
Right. Right. Right.
So inventory could be repositioned dynamically instead of once a month.
Hmm.
Production plans could respond to real constraints instead of just assumptions. And logistics could be reoptimized continuously instead of only when there is a crisis, right? So that's the real shift from planning sporadically or periodically to managing continuously. And that's really the goal.
Yeah. Yeah. And that continuous, like, I mean, we've talked about it a lot. There was several actually lectures you did on this, but I remember when we did a trip down to Flex,
Mhm.
that was exactly what the problem they were trying to solve is how do we get our decision making into as close to real time and get as much of the input in, and this ocean of data that's so fragmented that is very difficult. And sometimes it's not even that all of the data, even if your data is clean, there's so many inputs that you need from other third party sources. So getting that data AI ready is very is the real challenge, because the compute and the modeling is there. It's just, can we get the right inputs in there?
Absolutely. And the other point I would make is these capabilities are not just a way to manage costs or control costs. It can be a key differentiator in your markets. I mean, if you have two companies that produce the same product, but one can do it faster and quicker and respond to changes quicker, that becomes a key differentiator and a key competitive factor. And so it's not just a set of strategies and approaches that affects the cost side of the equation. It can have a material impact on revenue and therefore your competitiveness.
Absolutely, absolutely. So then, kind of the last couple of questions. One last one on the AI side is, as AI becomes more embedded in supply chains, do you see the role of supply chain managers evolving from planners to like decision supervisors?
Absolutely. I mean, I see the role shifting from a planner to an orchestrator. Managers will spend less time building spreadsheets, although I love doing that, but more time setting objectives, defining constraints, reviewing scenarios, and handling exceptions. So let me give you an example of an innovative EMS provider based right here in the Silicon Valley. By building automation and intelligence in their procurement processes, almost 85% of the procurement orders require zero human intervention. Think about that. Now, that leaves their buyers and supply chain managers with the time they need to focus on those 15% of really sticky orders that require manual intervention, negotiations with suppliers, or interactions with engineers or customers for creative solutions to complex problems, exactly where judgment really matters.
Correct.
So with AI, the human role is not going to disappear. It's going to move up a level
Yes.
from calculating decisions to governing how decisions are made, right? So from problem solving to shaping outcomes. And I think that's going to be a fantastic change, and it's going to enrich people's work significantly.
Yeah. And as you said, it's a very exciting time. Uh, and the reality is that the Pandora's box has been opened, and it's not going to reverse any longer. Adoption is key, and understanding how to work with this technology versus trying to fight the I don't love AI concept it's the reality is to stay competitive, the adoption must be there. So it's I mean, and to a certain extent, it also, like you had said, it gives us an ability to level up and produce more output and be able to do more challenging things. Like, to me, that's exciting. Though you love spreadsheets, I hate spreadsheets. So for me, that allows me to do the work, the creative work, the hard work around what to do next. And so, so
I think
let's
you're absolutely right. I mean, most people join these functions not because they love the math or the formula. They're there because they like problem solving.
problem solving. Yeah.
They like to be creative. They like to add value to whatever organization they are a part of. I think these advanced technologies are going to make it easier for employees to realize that potential.
So let's look ahead now, the next 3 to 5 years. What do you believe is the biggest challenge to supply chain resilience, especially when it comes to disruption, data complexity, or maybe it could be something else entirely?
Well, disruptions will always happen. We can't prevent those. But I believe that the bigger risk is slow decision making inside the organization. Supply chains today are incredibly complex, becoming even more so, with huge amounts of data and many stakeholders involved. And this complexity is increasing. If companies can't turn that information into fast, trusted decisions, even small disruptions can become very big, huge problems. So, in
That's
my
right.
view, the real threat is not the next shock, it is decision latency.
Decision latency. We'll take that away, and couldn't say it better myself. Once again, Dr. Agarwal, this has been a fascinating conversation, and I think the work that you've done on the paper for uh, OML, I think is a really fascinating way to look at a very old school traditional process. And so truly appreciate you being on and sharing all your insights.
Thank you very much, Manjot. I really enjoyed this conversation, and I hope this is informative and valuable to your audience.
I hope, and it will be. Thank you.
Explore our channel for more exclusive industry insights to keep your business ahead. If you enjoyed this, please like, share, and subscribe.